Good morning and welcome to lesson 2 of module 6. Today we are going to be able to interpret the rate of change in the initial value in a line within the context of a word problem. You'll know you're successful when you can interpret the slope as the rate of the change, and you can relate that slope to the steepness of a line and the sign of the slope, whether positive or negative, indicating that the linear function is increasing if the slope is positive and decreasing if it's negative. We're going to do some examples together. You'll do some exercises. We'll complete a closure, and then we will do our exit ticket and reflection. Okay? Please make sure your video is on. You are participating in the chat. You're showing your thinking, and you're asking me questions when you come across them. Let's get started. All right, beginning with this first example, it says, the equation of a line can be interpreted as defining a linear function. The graphs and the equations of lines are important in understanding the relationship between two types of quantities, which will be your x and your y. In a previous lesson, we didn't actually do this, but it says that we did. You encountered an MP3 download site that offers downloads of individual songs with the following price structure. A $3 fixed fee for monthly subscription plus 25 cents per song. Okay? The linear function that models this relationship between the number of songs you download and the total monthly cost is written as y equals 0.25x plus 3. X represents the number of songs downloaded, and y represents the total monthly cost for those downloads. All right? What I want you to do really quickly before we jump into this lesson is tell me, in your own words, what does this 0.25 represent? Okay, so explain to me what that represents here. And then I want you to tell me what this 3 represents. And explain to me that right here. Okay? In your own words, tell me what they mean. And then we'll go over it. This is a little bit of review before we start our lesson today from what we worked on yesterday. Okay? I'll give you about 1 minute to get some answers down. All right, well, I'm going to go ahead and show you what I would write down here, and our answers might be a little bit different, but they should have some commonalities, okay? So in my own words, 0.25 in this equation is the rate of change. Okay? Oops. And what that means is that for each song, you'll pay 25 cents. All right? So you should have something similar written down there, just letting me know that it represents the 25 cents per song. All right, that was written up here in our description. And then below for B, it says, explain the meaning of the 3 in the context of the problem. Well, 3 is our initial value. Meaning that the subscription costs $3 each month. No matter how many songs you buy, no matter if you even buy songs at all that month, you have to pay the $3 subscription fee. Okay? So this is what we went over yesterday, interpreting our equations. We're just going to continue with this learning today and really look at our slope, about it being positive or negative, but really continuing with this learning and building on it. Please make sure you have this down before we move on. So before we move on to the next screen, I just wanted to go over this one more time. The values represented in the function are interpreted in this way, and this is going to be any time your equation is written in slope-intercept format. Your slope or your rate of change is going to be here, and your initial value or your y-intercept is going to be here. This is your M, and this is your B. Again, we are really diving into what these things actually mean today. I'm going to go through and read these little descriptions down below. It says the coefficient of x, which is this number right here, your m value, is your rate of change. It can be interpreted as 1 unit increase in the value of x. So when it's positive, it's increasing. That's like our last equation where for each new song we pay more. It increases, so it's positive. Okay? But there are situations where it is decreasing, and that's going to give you a negative slope. So maybe if you're talking about the value of a car, each year a car loses its value a little bit more. So if we're saying, okay, well, in the first year that you have a car, it loses its value by $1,000. In the second year, it's lost $2,000. In the third year, $3,000. So your rate of change would be decreasing or a negative rate of change. So we're going to get into that a little bit more today. And then over on the right side, the constant value is referred to as the initial value or your y-intercept. It basically tells you when this number is calculated with a 0 as your x. So maybe when you purchase 0 songs, like in our last example, how much are you going to pay? Well, you're still going to pay that initial value of $3 each month. Okay? So this is what we're going to work on today. Let's go ahead and get started on the next slide. All right, we're going to continue with the same kind of situation. It says another site offers MP3 downloads with a different price structure. A $2 fixed fee for a monthly subscription plus a fee of 40 cents per song. So it's a little bit different in our pricing here. It says write a linear function to model this relationship between the number of songs and the total monthly cost. X is going to represent the number of songs. Y is going to represent the monthly cost. So we know that we're going to be writing this in the form of y equals mx plus b. All right? We know that y represents the monthly cost or total cost. M, this is going to be our constant rate. X is going to be our number of songs. And B is going to be our initial value. So this is what each part of this equation means. And now we just need to change it to the numbers they actually give us in this situation. So we're going to have a 2 and we're going to have a 40 cents. Well, our $2 is a fixed fee, which means you're going to pay this every single month no matter what. You're not multiplying this by anything. It's never going to change. So this is our initial value. Okay? And then we're paying 40 cents per song. That means we're multiplying 40 cents times every song. So where are we multiplying every song? Right here. So what's going to be multiplied by that? 40 cents. So the completed equation is going to be written as y equals our m, our constant rate, is 40 cents, x plus our initial value, which was $2. So this is our equation that represents this specific price structure. All right? It then goes on to ask us a question where we're going to use this equation. It says, determine the cost of downloading 0 songs and 10 songs from the site. So let's do 2 rows, or 2 columns. I'm going to do 2 equations. So I'm just going to start with the equation that they give me, y equals, or that I created, y equals 0.4x plus 2. You'll notice that I wrote 0.4x instead of 0.40x. That is the same number. You do not need this extra 0 on the end. Okay, it just takes up space. So for 0 songs, I'm going to be changing wherever the songs is represented to a 0. So our songs is represented by this x. So that means I'm going to change this x to a 0. It becomes y equals 0.4 times 0 plus 2. When I solve this out, 0.4 times 0 is 0. And 0 plus 2 is 2. So for 0 songs, you'll pay $2 that month, right? You still have that initial fee to pay. Go ahead and I want you to figure out right now how much you're going to pay for 10 songs. So please change your X value to a 10 and solve and tell me for 10 songs how much will you pay. We'll go over this in about 30 seconds because it is super quick. All right, so 0.4 times 10 is 4. And then we do 4 plus 2. This is 6. So when X is a 10, Y is a 6. So what this means is that for 10 songs, you will pay $6 that month. Okay? Please make sure you have this down. Please let me know if you have any questions about how we did this work or what we're doing or numbers that I've written down. And then we're going to move on. We're going to continue with it on the next slide. All right, continuing here, it says the graph below already shows the linear model for the first subscription company. So that first company that we talked about on the very first slide was Y equals 25.25x plus 3, or it's basically saying 25 cents a song plus $3 for a subscription fee each month. And they graphed it as this line. So you'll see they graphed the B value right here. They started with their y-intercept at positive 3, and they're going up 25 cents over 1. So they're going up 0.25 over 1 over time. Okay? We are now going to do a graph for company 2. So first we need to remember what the equation was for company 2. It was y equals 0.4x plus 2. Okay? So we need to know that we are starting, our initial value is a 2. So we're going to be starting right here. This is where our line is going to start. Okay? Now for one song, we're going to pay $2 plus 40 cents. So we're going to pay $2.40. So for one song, I'm going to go up to about $2.40. It's going to be right around here. Okay? For 2 songs, well, let me solve this real quick. Well, if you pay for 2 songs, each one's 40 cents, so that's going to be 80 cents plus the $2 monthly fee. So this is going to be $2.80. It's going to be right before the 3. Okay? For 3 songs, we're going to be multiplying 40 cents times 3. 40 cents times 3, that's $1.20 plus 2 extra dollars. That is $3.20. So we're going to go a little bit over our $3.20. Okay? We're going to do this all the way up. But first, let's just do our 10 songs because we know what our 10 songs was. We said we were going to pay exactly $6 for 10 songs. So we go all the way to 10. This is where it's going to be. And from there, I can just connect my lines. Instead of going through each one, I could go through each one of these and figure it out and make my line a little bit more straight. But I know my end value, so I'm just going to cross that up. Okay? So this represents company 2. All right? And what we want to look at here is where do these lines cross? Well, it looks like they cross at around 6. I'm going to double check that real quick. So if I were to turn this into a 6, would they have the same value? Would they both be paying, I think it's $4.50 or something at this time? So 0.4 times 6 is $2.40 plus $2. This is going to be $4.40. So this is $4.40. That is about where you pay the same amount of money for both subscriptions is when you buy 6 songs. Okay? You'll notice that company 2 starts off cheaper, but over time it's actually more expensive. So the more songs you buy, you realize, oh, company 1 is actually the better deal for me. Okay? And this is the case with most real-world situations. You figure out that, hey, this subscription might be better for my family because my family watches a lot of movies and we have to pay for every movie this much amount. Okay, but some people are like, I don't watch any movies. I would rather pay for this subscription because it just pays for streaming. So this is definitely a real-world application that you can do. We're going to continue with this on the next slide. I just want to make sure you have all this down before we get there. All right, here we're just going to interpret these a little bit more. So if we're thinking back to company number 1, our equation is y equals 0.25x plus 3. In company 2, it's y equals 0.40x plus 2, right? It says which company has the steeper slope. So if we look at their slopes right here, which slope is bigger? Well, company 2 has the steeper slope. Okay? And which one has the more expensive cost per song? Well, if we look at our slopes, this is talking about the cost per song, so company 2. You pay more per song with company 2. So that's actually what our slope represents, is how much you're paying per song. That's your constant right here. It then says, which one has the greater initial value? This is your B value. Well, company 1 has the greater initial value. You pay $3 per month for company 1 and only $2 per month for company 2, that flat subscription fee. Number 6 says, which subscription site would you choose if you only wanted to download 5 songs per month? Which company would you choose if you wanted to download 10 songs? I want you guys to figure this out on your own. So I'm going to give you about 5 minutes here to go through this and really determine for yourself which one is going to be better with only 5 songs and which one is going to be better with only 10 songs. And I'm not even going to tell you how to solve this. I just want to figure out, or I just want to know how you would figure this out, and then we'll go over it in about 5 minutes, okay? So go ahead and begin. All right, so how I'm going to show you how to figure this out is by writing both of your equations and solving. Okay, this is how you can do this accurately. So it says for 5 songs, how much are you going to pay for each one and which one's going to be the better deal. So I've written both of my equations for company 1 and company 2. And what I'm going to do is I'm going to change my x to a 5 for both and see which one is cheaper. So this becomes y equals 0.25 times 5. And this one, 0.4 times 5 plus that initial value. And we're going to solve both of these, okay? For this one over here, 25 cents 5 times is $1.25. And we're adding $3 onto that. So this is a total of $4.25 you'll pay for company 1. For company 2, 0.4 times 5, this is $2 plus another $2. Here you're going to be paying $4. So which one's the better value? Well, this one. If you're only buying 5 songs, company 2 is going to be cheaper. Okay, and then we're going to do the same thing over here on the right for 10 songs. So we're changing these x values to a 10 and seeing what they equal. So when we do 0.25 times 10, we get $2.50. We're adding $3 to that. So the total price for 10 songs for company 1 is $5.50. For company 2, when we do this, we get that 0.4 times 10 is $4 plus 2. It's going to be $6. So at 10 songs, which company is the better deal? Company 1. Okay, because it is cheaper when you do 10 songs. It's only $5.50, while company 2 is $6. So you'll notice here that depending on your specific situation, a company would be better for you. Okay, we are now going to move into a little bit of practice with this kind of concept. All right, moving into your first exercise, it says when someone purchases a new car and begins to drive it, the mileage, meaning the number of miles the car traveled, immediately increases, right? You go 1 mile, your speedometer or your Mileage gauge shows, oh, you've gone 1 mile. If you drive 50,000 miles, it's now going to show on your dashboard you drove 50,000 miles. It says let X represent the number of years since the car was purchased and Y represent the total miles traveled. The linear function that models this relationship is Y equals 15,000x. Okay, what I want you to do right now, tell me what the rate of change is, tell me what the initial value is. And tell me, is the mileage increasing or decreasing each year according to this model? We're going to go over this in about 1 minute, so please have answers here. All right, for the first question it says identify and interpret the rate of change. So my equation is y equals mx plus b. Remember, this is your rate of change and this is your initial value. So when I'm looking at this equation they give me here, I have y equals 15,000x and that's it. So it's plus 0 at the end. There's nothing being added on. So we're going to interpret the numbers they give us here. The rate of change is your m. So the rate of change here is 15,000. And what does that rate of change mean? We have to interpret it. So each year, you drive 15,000 miles. That is what it means in this equation. Okay? Next, we're going to be looking for the initial value. Well, the initial value is your b value. We didn't have one here. It was this 0. So our b equals 0. What does that mean? So it means basically before you start driving, there's no miles on this car. There are 0 miles on the car. Okay, and then the last question here says, is the mileage increasing or decreasing each year? Well, if you start off at 0 when you buy the car, and you go a year and you drove 15,000 miles, did that number increase or decrease? It increased, right? It's increasing by 15,000 each year. You can never go backwards. And what this means is that this is going to be a positive slope. So if we were to graph this, because it is increasing, our rate of change is positive. Okay, please make sure you have this down, and then we're going to move on to exercise number 8. All right, exercise number 8, very similar to the last one, we're going to do the same thing. It says, when someone purchases a new car and begins to drive it, generally speaking, the resale value goes down each year. Okay, let X represent the number of years since the purchase, and Y represent the resale value in dollars. The linear function is this. Okay, it says identify and interpret the rate of change. Well, first you need to look at your equation and make sure it's written in the correct format. We want our equation to say y equals mx plus b. Right now our equation says y equals 20,000 minus 1,200x. Okay, so our things are a little bit mixed up. We need our mx to be first. Okay, and we need our b to be second. So we need to rearrange this. We cannot rearrange this equation until we get rid of this minus sign right here. So I'm going to change this to a plus negative sign. From there, I can rearrange it. So now I'm going to put my negative 1,200 at the beginning and my 20,000 at the end. Okay, now I'm following the format y equals mx plus b. So this is the same equation as this. We have just rewritten it to follow the correct format. Okay, So looking at this equation that I just highlighted in yellow, I want you to identify and interpret the rate of change. I want you to identify and interpret, means tell me what it means, the initial value. And then I want you to answer this question. Is the resale value increasing or decreasing each year? Explain it. Okay, take about 5 minutes to do this before we go over it. All right, starting with part A. The rate of change is your M value, and it comes right before your X. So the M value here is negative 1,200. What does this mean? This means each year the car loses $1,200 in value. That's called depreciating. Okay, so it's worth $1,200 less than it was the year before with each year that goes by. Okay, then it says identify and interpret the initial value. Initial value, this is how much the car was initially worth. So our B value here, our initial value was 20 grand. Okay, and what this means is that the car was originally $20,000 when it was bought. C says, is the resale value increasing or decreasing each year? It is decreasing. It loses value each year. It's worth less. Specifically, it's worth $1,200 less. Which means that if we were to graph this, we would start at $20,000 up here, and it's just going to slowly lose value until one day it's worth nothing. Our slope is negative. Okay, please make sure you have this down before we move to the next slide. We are actually going to skip this slide number 9 just for the sake of time, and we're just going to move on to the next one. Our lesson summary is that when a linear function is given by the equation in y equals mx plus b format, your rate of change is your m, and your initial value is your b. They're easy to identify. What's a little bit more difficult is interpreting it, okay? So just within the context of your situation, make sure you're reading through that and understanding what it actually means, okay? Going on, positive rate of change means that it is increasing. Negative rate of change means it's decreasing, and you'll see that graphed as a negative and positive slope, okay? When you have two positive line slopes, the one with the steeper value is the one with the greater rate of change, okay? The initial value of a linear function is the y variable when the x is 0. It is your y-intercept. And that is our lesson summary. Let's get into our exit ticket. All right, this is your exit ticket for today that you will do in Galileo, but I just want to go over it before then. It says in 2008, a collector of sports memorabilia purchased 5 specific baseball cards as an investment. Let Y represent each card's resale value in dollars, and X represent the number of years since the purchase. Each card's resale value after 0, 1, 2, 3, and 4 years can be modeled by linear equations as follows. So you'll notice that these equations they give you are not written in slope-intercept form. So you need to first rearrange these so they're written in y equals mx plus b format. It is not hard. I'll do the first one for you. So the first thing I'm going to do is change my minus sign to a plus negative, and then I'm just going to rearrange. I'm going to put that mx first before my b. Okay, so this is my initial value of, or this is my correct equation for card A. Okay, I want you to do the same for card B, card C, D, and E. Then you can compare them more accurately. Okay, number 1, it says which cards are decreasing in value each year. So you need to look at your M, your constant rate, and see which ones are negative. All right. Number 2, which cards had the greatest initial value at 0 years? So maybe it's two different cards that have the same initial value. You're going to tell me which ones were worth the most before they started getting older. So at 0 years, which ones were worth the most? Number 3, which card is increasing in value the fastest? Which one has the greatest rate of change? If you were to graph the equations of the resale values of card B and C, which one would be steeper? And then, lastly, it says write a sentence explaining the 0.9 in card C's equation. What does that 0.9 represent? Okay, so these are going to be your questions in Galileo. Again, it might help you if you rewrite all these equations in the correct format first. If you don't want to, that's completely fine. I'm not going to make you. You can see the N and the B values without doing that, but it just is good to be in that habit. Okay? When you're done with this, please complete your lesson reflection in Google Classroom.